Hello, good afternoon. Today's topic is lubricants, properties, its properties and application. I am Rosie Gupta giving this lecture from GPCG Ludhiana. Now, what is a lubricant? We must know first of all the substances which are used to decrease the friction between the moving parts of a machine in contact are called lubricants. For example, mustard oil, grease, mobile oils, etc. तो इसका मतलब ये है कि जो सब्सटेंसेस किसी भी मशीन के जो मूविंग पार्ट्स होते हैं उनके बीच में जो फ्रिक्शन पैदा होती है उसको जो कम करते हैं उनको हम ल्यूब्रिकेंट्स कहते हैं। तो कोई भी ऑयल जो है एक तरह से ल्यूब्रिकेंट का काम कर सकता है, लेकिन हमें कुछ स्पेशल ऑयल्स चाहिए होते हैं जिनकी कुछ स्पेशल एप्लीकेशंस होती हैं और कुछ स्पेशल प्रॉपर्टीज़ होती हैं। रूटीन में जो हम लुब्रिकेंट्स यूज़ करते हैं उसमें आते हैं मस्टर्ड ऑयल्स, ग्रीस एंड मोबिल ऑयल्स। Now lubrication, what is a lubrication? The process of decreasing the force of friction between moving parts of a machine in contact is called lubrication. इसका मतलब ये है कि जब भी कोई ल्यूब्रिकेंट हम अप्लाई करते हैं फ्रिक्शन को डिक्रीज करने के लिए, जिस तरह से वो ल्यूब्रिकेंट अप्लाई किया जाता है उस प्रोसेस को ल्यूब्रिकेशन बोला जाता है। टाइप्स ऑफ ल्यूब्रिकेंट्स 3 टाइप्स के होते हैं, लिक्विड ल्यूब्रिकेंट्स, सेमी सॉलिड ल्यूब्रिकेंट्स एंड सॉलिड ल्यूब्रिकेंट्स। Now applications of the lubricants. Now every type of lubricant has its own advantages and disadvantages. Therefore, each and every lubricant is used according to machine and its use in industry and at home. It means if any lubricant can be used in industry, it does not mean that it can be used at home. This is what we mean by its own advantages and disadvantages. So when we select a lubricant, we have to keep in mind 3 things. First of all, whether it is to be used in the industry. Second, whether it is to be used at home. Third, the machine, the purpose for which the machine is to be used, कि जिस पर्पस के लिए वो मशीन यूज़ होनी है, चाहे वो इंडस्ट्री में है चाहे वो घर पे है, उसके ऊपर डिपेंड करेगा कि हम कौन सा ल्यूब्रिकेंट जो है उसको चूज करेंगे। Now applications of the liquid lubricants. The first is as anti-wear, antioxidant and anti-foaming agent. It means we are talking of 3 functions. First is anti-wear, means it should be able to stop the damage to the machine. Second, we are talking of antioxidant. It means we are talking that the oxidation of the lubricant, that is reaction with the oxygen present in the air, should not take place. Third, we are talking is of anti-foaming. Anti-foaming means कि lubricant should not mix with other dust particles etc. present in the air to form foam. So it should be an anti-foaming agent, because if a lubricant is not able to do these things, that is stop the damage or stop the oxidation or stop the formation of foam, then that lubricant is not going to be a good lubricant. Second is as demulsifying and emulsifying agents. Now these 2 terms are actually opposite, emulsifying and demulsifying. Sometimes we need a lubricant which should emulsify, that is mix with the moisture and form an emulsion. Second is कि it should break that emulsion and de-emulsify itself and again go back to the liquid lubricant, that is oil, and the moisture form. Third is as rust and corrosion inhibitors. Now, lubricant should be able to stop the rusting of the different parts of the machine. Then fourth is in machinery, as engine oils, compressor oils, gear oils and piston oils. Now, in automobiles especially we are using different parts, engines, gears, pistons within the engines. So, every part is actually moving at one time or the other, that is by moving it is producing some friction. Now, we have to reduce that friction. Now, we reduce that friction with the help of engine oils within the engine, compressor oils within the compressor, gear oils for the gears and piston oils for the working of the piston. Fifth application of the liquid lubricants is as hydraulic, brake and gearbox fluids. Now, lubricants are also used as in the hydraulic brakes for them to function properly and in the gearboxes to change the gears easily. Then sixth is it is used in the soap and paint industry in the different machinery parts. Then seventh is synthetic liquid lubricants are used in turbines, vacuum pumps and semiconductor devices. Now, synthetic lubricant means the lubricants which are prepared from the crude petroleum. Now, in this we add some additives also and improve their functioning. Now, therefore, we are using it in the turbines where which are used to produce the electricity, then in vacuum pumps where the vacuum is created and which are used to create the vacuums, and third is in the semiconductor devices, because all these things they need particular applications of the particular parts. So, they need a particular lubricant. Then eighth is as cutting fluids in the industry. Cutting fluids means the lubricant which is used in the cutting tools in the industry. For this purpose, oil, water and oil emulsions are preferred. Now, here as I was talking of emulsing and de-emulsifying agents, now here we need an emulsifying agent, that is an oil which can mix with water. So, in liquid lubricants we need something which is going to produce an emulsion and carry off the heat produced by the cutting. Then is application of the greases. Greases are semi-solid lubricants which are formed by mixing together soap, oil waxes, fats and petroleum residue. Now, greases it means that greases are obtained from the crude petroleum. Now, crude petroleum has different fractions. Out of it, one fraction is of waxes, which are known as oil waxes. So, when we mix the soap, oil waxes, fats and the petroleum residue, we get something which is called a grease. Now, this is semi-solid, it is not liquid. Now, grease is applied to those machineries which run intermittently or are stored or remain idle for prolonged periods so that lubricating film remains on place for long time. So, it means कि semi solid lubricants are used in those machines which are used seldom, sometimes only, and which have to be kept in the store for the long periods, so that when we run those machines we do not encounter any friction problems. Second is when frequent lubrication is not possible in the machines. So, greases are also used in those machines where we cannot use the lubrication daily or on the hourly basis. So, we are using the greases there. Now, high quality greases can lubricate isolated or relatively inaccessible paths for long time periods without frequent replenishing. Means we do not have to apply the greases again and again, say after 2 days or 3 days. We can apply the greases after a week or after 15 days or after a month also, because these are not going to get off the machine parts. Now, these are also used in the sealed form for life applications such as some electrical motors and the gearboxes. So, greases are also used in some electrical motors or gearboxes in the sealed form, where that is why we do not have to apply them again and again. Then in those machines which work under extreme conditions of high temperature and pressure, shock loads or slow speed under heavy loads. So, these are also three things. First is high temperature and pressure, where the oils decompose, and shock loads or slow, second is shock loads, means the force which is going to apply on the machine is in the form of a shock, such as sudden brakes in an automobile. Then is slow speed under heavy loads, such as trucks moving and the axles of the trucks moving at very slow speeds. In these cases, greases give thick layer required to protect and lubricate adequately, whereas oil layer can break. So, it means that grease can stay on its place for a long time as compared to an oil which is going to break after some time. Then is greases maintain a thicker film in clearances increased by wear and tear. This extends the life of the worn parts. So, it means that the machine parts which get damaged due to say non-application of the lubricants or due to the bad oils which are used, in those cases sometimes the gaps are increased within the moving parts. So, we can reduce those gaps by applying the greases and decrease the friction and increase the life of the machine. Then is thick grease layers also provide noise insulation. Now, thick grease layers also provide noise insulation, means कि they act as insulators. Then is application of the solid lubricants. The solid lubricants are actually the powders which are used as lubricants, such as molybdenum disulfide. So, at high, or graphite is also used as a solid lubricant. Now, at high temperatures, say of the order of 1926 degrees centigrades, other lubricants tend to degrade or decompose. The that is, greases or oils can either degrade or decompose. They can react chemically, they can evaporate. So, such type of things can happen. Therefore, in such conditions, solid lubricants can prove an effective measure. Then in the same way, at low temperatures also of the order of minus 212 degrees centigrades, the liquid or the greases can solidify, and in the vacuum, that is in the space missions, these can volatilize. Therefore, in those cases also we can use the solid lubricants. Then is in those equipments which are stored for very long time and which are not in the working period. In those also we use the solid lubricants to provide a permanent non-corrosive lubrication. That is, now when we are going to use them after a long time, then we can use the machine easily without the frictions. Now, and this will protect our machine. Now, if the lubricant is satisfactory for the intended loads and the speeds, then solid lubricants have the distinct advantage of staying in place for inaccessible parts of the machines. So, it means that the solid lubricants are easy to apply in those parts by sprinkling where the oil or the grease cannot be applied. So, there also the solid lubricants are helpful. The last is that solid lubricants are helpful in those machines where fluids tend to pick up dust and lint, such as in the textile industry. The waste fibers can mix with the oil or the grease and increase the friction by making a paste. Therefore, in those cases the solid lubricants are going to be very helpful, because this will stop the irreparable damage to the equipment, means the damage which cannot be reverted. Then solid lubricants are also helpful in those machines where the migration of the liquid lubricants to other parts, equipments and products is not desirable. It means that the oil can move as a fluid from one part of the machine to the other part of the machine, but we do not want that to happen. Therefore, in those machine parts we will prefer to use the solid lubricants, because the solid lubricants are going to hold their positions and will not spread to the other parts of the machine. Then solid lubricants are effective in those applications where lubricated equipment is immersed in water. Now, that is very important, such as in submarines. Now, submarines are in the water most of the time. So, we need a lubricant for its engines or other equipments which is not going to mix with other things, say water or it is not going to damage the machine parts. So, there we can use the solid lubricants. Then are the properties of a lubricant. Now, a suitable lubricant can be decided for a machine after studying its properties. Now, we can select a lubricant depending upon its properties. The properties are of two types as usual, the physical properties and the chemical properties. The physical properties are related to the physical part of the, that is the looks or the other things of the lubricant, and the chemical properties are associated with the chemical reactions of the lubricant. The physical properties are the viscosity, viscosity index, flash and fire point, cloud and pour point, oiliness, volatility, color and emulsification. Now, let us study all these properties one by one, but before that let us see what are the chemical properties. First is total acid number, which is also known as TAN. Second is saponification value. Third is iodine value, then aniline point, then precipitation number, then Koch number. So, these are the chemical properties. Now, let us see what are the physical properties and what does it mean, what does these properties mean. First is viscosity. It is the most important property of a lubricating oil, as it determines the performance of an oil under operating conditions. That is, how the lubricating oil is going to perform under the operating conditions, that is decided by the viscosity, and the operating conditions are the temperature and the pressure under which the machine is working. So, we can define viscosity as the property of a liquid by virtue of which it offers resistance to its own flow. So, कोई भी liquid जो मूव करता है, चाहे वो वाटर ही क्यों नहीं है, हमेशा अपने फ्लो को रोकने की कोशिश करता है, और ये जो प्रॉपर्टी है इसको विस्कोसिटी बोला जाता है. सो वंस अगेन द प्रॉपर्टी ऑफ अ लिक्विड बाय वर्च्यू ऑफ विच it offers resistance to its own flow. So, it means anything which is more viscous than other will not flow easily. For example, mustard oil is more viscous than water. So, we all see that mustard oil it does not flow that easily as the water does. Therefore, we say that mustard oil is more viscous. Now, if the viscosity of an oil is too low, then the liquid oil film cannot be maintained between two sliding paths, and therefore, excessive wear will take place. So, it means that if the oil has the viscosity as that of water or less than that, then it is going to flow off the machine. So, there will be no oil layer on the machine parts. It means that the machine will be without the lubricating oil, and the wear and tear of the machine will take place, damage of the machine will take place. On the other hand, if the viscosity of the lubricating oil is too high, that is, it is not moving from one part of the machine to the other side of the same part, say, then excessive friction will take place, as the moving machine will not be able to slide easily. Means if the lubricant is not able to move from one part to the other side of the same part, even then the friction will increase. That is, higher viscosity will also increase the friction between the moving parts. So, low viscosity will increase the wear and tear, that is damage, and high viscosity will increase the friction. Now, how do we determine that viscosity is how much? That is determined by the coefficient of the viscosity. Now, let us consider the equation F is equal to eta V over D, where F is the force, eta is the coefficient of viscosity, V is the velocity by which the fluid is moving, and D is the distance between the two layers of the same fluid. Once again, F is the force, eta is the coefficient of viscosity, V is the velocity by which the layer is moving, and D is the distance between the two layers. Now, if V is 1 centimeter per second, that is, velocity is 1 centimeter per second, distance between the two layers is 1 centimeter, then the force is going to be equal to eta, that is coefficient of viscosity. So, we can define the coefficient of viscosity as the force per unit area required to maintain a unit velocity gradient. So, इसका मतलब क्या है? इसका मतलब ये है कि वो फोर्स जो कि 1 यूनिट वेलोसिटी ग्रेडियंट को मेंटेन करने के लिए ज़रूरी है, उसको हम कोफिशिएंट ऑफ विस्कोसिटी कहते हैं. तो जितना ज़्यादा ये कोफिशिएंट ऑफ विस्कोसिटी होगा उतना बैड हमारा लिक्विड लुब्रिकेंट होगा. Now units of viscosity. In CGS system, the units of viscosity are poise, but we generally express it in centipoise, and 1 poise is equal to 100 centipoise, whereas in SI systems the units are 1 Newton second per meter square, and 1 Newton second per meter square is equal to 10 poise, right. So, that means 1 Newton second per meter square is going to be 1000 centipoise. Now, the viscosity of the liquid decreases with the increase in temperature. In general, viscosity of any liquid, it decreases when we raise the temperature of the liquid, that is the force of friction between the moving layers of the liquid decreases. The relation is given by eta is directly proportional to 1 divided by under root of absolute temperature T. Once again, eta is indirectly proportional to the under root of the absolute temperature. So, this relation shows that as the temperature increases, the viscosity is going to decrease. Next is the viscosity index. The rate of change of viscosity of a liquid with the temperature is known as viscosity index. So, as we have seen that viscosity is going to decrease as the temperature is going to increase. Now, this is actually measured by the rate by which this viscosity increases or decreases as the temperature falls or as the temperature increases. Now, if the viscosity of the lubricating oil decreases rapidly, then we have low viscosity index. So, it means if the viscosity is increasing easily, decreasing easily with the increase in temperature, then we have low viscosity index, which is not necessary, which we do not need actually. On the other hand, if the viscosity of an oil decreases slightly with the increase in temperature, then it has high viscosity index. So, high viscosity index means ki rate of change of viscosity is going to be very high if the viscosity of the oil decreases slightly with the increase in temperature. Then are the physical, then is the flash point. Now, it is the lowest temperature at which the oil gives off enough vapors that ignite for a moment when a small flame is brought near it. Now, we have seen it generally, then when we take a burning stick to some oil wick, then it does not burn the same moment, because the oil first of all changes into vapors and then those vapors catch the fire. Now, flash point is that temperature at which there are enough vapors so that the flame which we have taken near to the oil wick, it ignites only for a second, but does not burn continuously. But if it burns continuously, then it is called a fire point. Now, a good lubricant should have high flash and fire point, at least above the temperature at which it is to be used. So, what does it mean? It means that the flash and the fire point should be higher than the temperature at which the lubricant is going to be used. So, if we are going to work at say 45 degrees centigrades, then the flash and the fire point should be above 45° centigrades. Now, as the lubricant having low flash and fire points may catch fire due to the heat generated in the moving parts of a machine. Now, if the temperature is low, that is flash and fire points are lower than 45° centigrade,